ABCD is a rhombus. Consider the diagram below and determine with reasons the size of angles A, B, C, and D. Let's start with angle A. A sits at the center of the rhombus, over here, where the diagonals intersect. We know that the diagonals of a rhombus are perpendicular and create 90-degree angles between them. So we can see that A must be equal to 90 degrees. And as our reason, we say that the diagonals of a rhombus are perpendicular. Let's take A out of our diagram. We can write in 90 degrees. Now we can look at the size of angle B. Please always keep in mind that even though we are working with quadrilaterals, we will still use what we have learned about parallel lines, angle relationships, triangles, and the midpoint theorem to help us answer these questions. Now, B sits in triangle AOB, so let's make it red. We know that the sum of the interior angles of a triangle will always give us 180 degrees. In this triangle, we are given an angle of 25 degrees, and we've just found that A is 90 degrees. So we can use this to find the value of B. So we can say angle B is equal to 180 degrees minus 90 degrees, the size of angle A, minus 25 degrees, the angle that we've been given. We know this is true because the sum of the interior angles of a triangle is always 180 degrees. Now we can take our calculator and we can say 180 minus 90 minus 25 gives us 65. So angle B is 65 degrees. Let's take B out of our diagram and write in 65 degrees. Now we can take our red triangle out and let's look at C. We know that the diagonals of a rhombus bisect the interior angles. C and B both sit over here in interior angle A. The diagonals bisect angle A, which means that it cuts it in half. We've just found that B is 65 degrees. C is the other half of angle A, which means that C is also 65 degrees because the diagonals of a rhombus bisect interior angles. Now in our diagram, let's take C out and we can write in 65 degrees. Now we still need to find angle D. There are many ways we can find the sizes of different angles in the quadrilateral. So what do we know about this rhombus? We know that opposite sides are parallel. Angle D sits next to side DC. So let's make the side blue. CD runs parallel to AB. So let's make the side blue as well. Now we know from our work with parallel lines and angle relationships that in order to find equal angles, we need two parallel lines and a transversal line. In this rhombus, there are two transversal lines, the diagonals AC and BD. Both transversal lines cut both of our parallel lines, but we only have one 25-degree angle over here at B, and we don't know much about angle D down here. So let's rather consider the transversal line AC. Let's make it purple. Now we've created a Z shape, and D sits inside the Z shape to the left of the transversal line. So let's mark this angle in green. Alternative angles sit inside the Z shape. So let's mark the alternative angle of 65 degrees in green as well. We know from our work on angle relationships that alternative angles are equal, which means that D must also be 65 degrees. We know that this is true because these are alternative angles. Remember that when working with angle relationships, we need to give a reason why. In this case, these are alternative angles because AB is parallel to CD, and we know that this is true because the opposite sides of a rhombus are parallel.